Hello everyone, welcome to today's class. In today's class, we're going to continue with our laws of indices, and today we are going to do with fractional indices. So let's start. So when you have x raised to power 1 over a, and you are being told to find the solve for it, how do you go about it? First, let's prove it. X raised to power a, 1 over a. So let's solve. Let's say we have something like square root of x multiplied by square root of x. What are we going to get? We are going to get x, right? Okay. Now we are trying to know how square root is giving us a whole number. So what we are going to do, say, let's assume this square root is a power of x. I will now say x raised power p times x raised power p is giving us x. Are we together? Yeah, this will give us x raised power 1, because once you have a, remember what I said in English, once you have a number that doesn't have power, there is a hidden power of 1 here. So by so doing, we are assuming that this square root of x is x raised power p, right? As I have x raised power p times x raised power p equals x raised power 1. So what we are going to do now is, if you are using the law of indices, the first law that says that when two indices multiply each other, it is the same as x raised power p plus p. If I'm equating it, is to still give me x raised power 1. Remember how we solve our indices, that once the base are the same, it means that whatever that is up are the same too. So I will have p plus p is 1, 2p is 1. Therefore, p is 1 over 2. So by so doing, we now know that square root of x is the same thing as x raised to power 1 over 2, if you are to express it in power form. So with this, we're able to prove that, because normally when you have a square root, there is a hidden 2 here. Now it's from when you start having something like cube root, fourth root, that's why the number will start showing. So if we are to write this is the same as 2x. So what it's trying to say is now is that the value here is a fractional indices of x. So let's do for the cube root so you understand better. Let's assume we have cube root of x. Now we have to put the 3. As I said, once you start having higher root, you must put the root here to indicate it. But if you are dealing with square root, you don't really need to put it. Anybody that see the sign like this knows that you're talking about square root. So you have x times cube root of x times cube root of x. Normally, when the 3 cube root multiply itself, it will give you 1. When you're dealing with cube root, when a cube root multiply itself 3 times, like this is a cube root, this is 3. So it means that this thing multiply itself by the number here, it will give you 1. Sorry, I made a mistake. It will give you x. It will give you the number inside the root sign. The same way we have square root here. This is a hidden 2. So when it multiplies itself 2 times, it's giving you the value. So now, let me call this one number 1, call this one number 2. So the next thing we are going to do, let's call this q. Let's call this q. Or let me say, let's call it x raised to power q. Because we don't actually know the power of this, so we are trying to prove it in this class. So I will now have x raised to power q times x raised to power q times x raised to power q. This is giving us x. Remember that this is giving us x. So for that reason, when we call this x raised to power q, it will also give us x, the same thing we did up here. But no, when you have x, there is a hidden 1, not forget. So it will be x raised to power q, when we use the normal law of indices that we know, plus q. This will give us what? X raised to power 1. Because the bases are the same, we now have, let me space it, q plus q plus q is equal to 1. 3q is 1. Therefore, q is 1 over 3. So now we're able to prove the cube root that this is the same thing as x raised to power 1 over 3. Conversely, this too is the same thing as that. So from this, we can now say that when you have x raised to power 1 over a is equal to the root of x in the power of a. So if you have, let me say you have something like x raised to power 1 over 5 is the same thing as the fifth root of x. Now the second thing we are going to prove is this x raised to power a over b. How do we solve for that? S raised to power a over b, we all know is the same thing as x raised to power. What makes up this a over b is the same thing as 1 over b times a. 1 over b times a will give you, when you solve the math, is same thing as a over b. And according to our law of indices, when you have something like this, you can also express it as, let me say this will be 1 over b all raised power a. Like when the power is raised to another power, is same thing as a multiplication of that power. So if we are now to change this to this form, we'll have something like this. Since a over b, we already know that that one is the b root of x all raised to power a. So when you have something like this, the one under the fraction will be the root of x, while the one on top of the fraction will be the power of x. Let's solve an example. Let's say we have something like, let me say 3a, x raised to power 2 over 3. So your answer will simply be, the 3 is under the fraction, so it will be the root of 3, or bracket 2 is on top, the square of 2. So let's start solving an example so we get to understand it better. So these are the examples we are going to solve. First, 9 raised to power 1 over 2. From our rule, 1 over 2, the one under the denominator of the fraction that the base is being raised to will give us the root. So 9 raised to power 1 over 2 will simply give us square root of 9. You can put 2 here, you can sign not to put 2 here. So let me just draw a line so that we can solve everything in one page. So here now we have square root of 9 is what? 3. Because 3 times itself is what will give you 9. But then there is something we need to take note of. You will see it's either plus or minus 3. You know, when you're looking for square root of an even number, you don't really know which part of the number gives that answer. Let me give you an example. Minus 3 times minus 3 will still give you 9. At the same time, 3 times 3 will give you 9. So when you're looking for square root of even number, like this is square root. If you have like something like fourth root is like when you have something like 16 raised to power fourth root. That's what you multiply itself by 4 times to give you 16. The answer is 2. So in this case, let me call this one 1b. It's an example. In this case, the answer will plus or minus 2, because minus 2 times minus 2 times minus 2 times minus 2 will give you 16. The same way, 2 times 2 times 2 times 2 will still give you the same 16. So when you are looking for square root of the root where the root here is even, you don't know whether it's plus or minus, because when minus multiplies itself evenly with an even number, it gives plus. So but when you are looking for the one that is odd number here, if you get plus, know the answer is plus. If you get minus, know the answer is minus. Odd number, the negative sign shows itself. But for the even number, you don't really know which of them. So when you want to get this type of answer, you usually see this kind of thing. That's why I'm trying to explain it. You have something like plus or minus. What it means is either this is plus 2 or this is minus 2. You don't know the actual one that gave rise to the answer. So let's solve the next one. The next one is number 2, which is 8 raised to power 1 over 3. According to our law, it will be 8, the cube root of 8 in this way. What we multiply itself 3 times to give you 8? The answer is 2. We just write 2. Now we can be 100% sure that the answer of this is 2 because it's an odd number. Imagine if it's negative, we have minus. If, let me say, we have minus 2 times minus 2 times minus 2, it will give us minus 8. So once it's an odd number and it has minus, the answer will still be, we will see minus in the answer. But if it's an odd number, it does not have minus, we know that it is a positive answer. So this 2 is the answer for this one. You don't need to check whether it's plus or minus. It's clear. Let's go to the next example, number 3. We have 8 minus 2 over 3. Now, remember, whenever we have negative in our indices, what does it mean? We change it to 1 over that value. So this will be 1 over 8. Now the negative will go. It will now be 2 over 3. Hope you get it. Because there is negative here, you do the inverse. That's the law we did in the previous class. So now, remember what we just did when we are proving this. This will give us, this will be the root. So root 1 over 8 all raised to power the 1. The numerator is the power it will be raised to, while the denominator is the root it will be raised to. So let's solve what is inside the bracket. 1 over 8, cube root of 1 over 8 will give us 1 over 2 all raised to power 2. So 1 over 2 times 1 over 2 raised to power 2 is the same times 1 over 2 times 1 over 2. So this is equal to 1 over 2 times 1 over 2. So the answer here is 1 over 4. So the next one we are going to solve for is this, number 4. Number 4 says 1 over 6 times 4 raised to power 1 over 3. Here we apply the multiplication law that we did earlier. That when the bases are the same, so it will be 4 raised to power 1 over 6 plus 1 over 3. When you solve this, you get 4 raised to power you get 4 raised to power 1 over 2. How do I get this 1 over 2? I just added this and this. I didn't add it in this class, so this class will not be long. So this is the same thing now. Then now we have to apply our fractional law of indices here. We now have the denominator is the power of the root, so it will be square root of 4, which we said earlier that is plus or minus 2. The last example I would like us to solve, we call it number 5, is 16 over 81 all raised to power minus 3 over 4. Now, first, what are we going to do first? We sort out this negative sign. When we remove this negative sign, we have something like, this will now be equal to 81 over 16 all raised to power 3 over 4. Negative sign after. What did I do? I brought the 81 up and brought the 16 down. Why? Why is it like that? Normally, whenever you have negative sign, it means 1 over the value. So let me solve it. You have 1 over 16 over 81, right? Which is the same thing as 1 divided by 16 over 81. Remember how we solve for division? You now have 1, let me call it 1 over 1, same thing as 1, times. When you add times and remove division here, you flip the value. It will be 81 over 16. So 1 times 81 is 81. 1 times 16 is 16. So that's how I flip it. So instead of it, we're going through the long process of the 1 over. Whenever you have two values like this, flip it. It will give you the same answer. But if you have a whole number, you can just say 1 over that whole number. Hope it's clear. So now we've solved out the negative sign. Next, we are going to sort out is these signs here. So here is the power of the root, where here is the power. So we have something like this will translate to 81 over 16. 4 will come here. 4 raised to power 3. Now, what are we going to do? The fourth root of 81. The fourth root of 81 is what? That's, if I'm not wrong, that's 3. While the fourth root of 16 is 2. Mind you, because here is even, you still have to put that plus or minus. Or is power 3. Hope we are making sense. So Now this 3 will multiply what is up and what is down. So the answer is 3 raised to power 3 is 27 and 2 raised to power 3 is 8, plus or minus. So what determines the plus or minus is the root, not the one here. Hope we get it. So this is it about fractional indices. Let's solve one more. So I choose this example because it looks like summary of everything we've done in this class. The power is here, and we have the negative, the division, multiplication, and everything. So the first thing I'll do, I'll change it to, I'll sort out this sign here. So this will be this 72a 3 b raised power minus 2 all divided by 2a raised power 5 b raised to power minus 6. So let's start solving. So we've sorted out the fractional indices. Next thing, we have to solve everything inside here. This will be equal to, let's start. 72 divided by 2, I have 36 times 3a divided by 3 a raised power 3 divided by a raised power 5. Remember the law is dividing, so there will be negative. It will be a 3 raised power 3 minus 5. B raised power minus 2 divided by b raised power minus 6. It will be b minus 2 minus 6. All making sense? So this will be 36 times 3 minus 5 is a raised power minus 2. Then minus 2. That this minus multiplied by this minus in the bracket will be plus. So it will be times b raised to power minus 2 plus 6. So this will give us 36 times a raised to power minus 2 times b raised to power 4. So if I have to find the square root of all these values, we have something like, now remember, you are looking for square root. This is an even number, so after solve we have plus or minus, so we don't get confused as I'm emphasizing on this. We have plus or minus first. We have square root of 36 will give us 6 times square root of a raised to power minus 2 will give us a raised to power minus 1. We all know how to solve for square root. It means divide the power by, if we are talking about variables like this, just divide the power by 2. That's what it means. Remember when we converted this thing here? So it means that this power will sort out each and every one of them. So here now, this will be b raised to power 2. 4 divided by 2 is just 2. This is your answer. So your answer will be this. But then you remember that there is a negative sign here, so you have to sort it out. So it will be equal to plus or minus. Let me remove this multiplication sign. 6b squared all over. This is minus 1. Sorry. Because minus 2 divided by 2 is minus 1. Sorry for the mistake. So all over a. Now when I take a on, I don't need to put reason when it's on top there. This minus 1 need to be here because negative sign is very important to indicate. But here now, as it's down here, it's just a raised to power 1, and any number raised to power 1 is still that number, so you don't need to put the indices any longer. So this is your answer. Assigning these negative indices, I just want to use this to just show how you convert them. You have this, and if you want to remove the negative sign, remember p q raised to power minus 2. Now, mind you, this minus 2 only applies to this q. If it applies to both of them, there will be a bracket to show that it applies to both of them. So for this p q raised to power minus, you want to change, you want to put it in a form where the negative sign will be missing. It means that this q now is something like p over q square. Let's go for this one. If you want to remove the negative sign here, means this will come up and that will come down. Remember what I told you, if you still solve the long process of 1 over this, you still get the same answer. So this will give you b over 2a. The negative sign is out. But now, in this case, see how the power applies to all of them. That's why it's in a bracket sign. So the power still remains the same. So whenever you see negative sign, try to know how to solve. If it's a whole number, only the whole number will just go down. Here now, this is the same as P times 1 over Q all squared. But when you join it together, you get this. But whenever you have it, whenever you have a minus that involve a number that have numerator and denominator, the short form, you just flip the number, let the denominator become the numerator and the numerator becomes the denominator. Instead of going through the long process, since the negative sign is affecting both of them, to just flip. But if it's a whole number, only the whole number will go down to be 1 over the whole number. Thank you. We're going to solve more examples on this, how to look for x in our next class. See you in the next class.